Okay guys, so we're heading into our third project. This one is all about regression analysis and scatter plots, right? Okay, so I'm going to read number one. Many universities use SAT scores as one of the criteria for admitting new students. Are SAT scores good predictors of college success? To answer this question, a researcher looked at a random sample of SAT scores for students admitted to a local university and their GPAs after completing 60 credits at the university. The data is found in our SAT tab of our Excel data, which I'll pull up in a moment. Create an SAT score versus GPA scatter plot of the data. So the thing that I want to prep you for, especially in our homework and on our exams, is when you're creating a scatter plot, you want to think about what's the independent variable and what's the dependent variable. What's going to be your X and what's going to be your Y. So the question here, they use SAT scores. Actually, they're wondering, are SAT scores good predictors of college success? So if you can envision, let me pull this up. Pull up the Excel file here. See? Okay, and let me zoom in. Okay, so here we have GPA and here we have SAT, right? So is the SAT score a good indicator of, how well they're going to perform? Well, clearly not with this person that got a 1300 on the SAT and has a fairly low GPA. It could be an outlier. So anyhow, this will be our X data, and this will be our Y data. Let me use my eraser here. It's a little blurry. Okay, so this is our X, and this is our Y. You have to just decide what variable is going to be predicted, and what variable is going to be your explanatory variable. So SAT scores are explanatory variable here, and then their GPA is the response variable. Okay, so for starters, we're supposed to make a scatter plot. So I'm going to use, you can make a scatter plot with just regular old Excel, but remember I'm always using my Megastat add-in. So I'm going to go to add-in, Megastat. I'm going to go down to correlation and regression. I'm going to slide over to scatter plot. Okay, and it asks you, what do you want to be on your horizontal axis? So we want SAT scores, so we'll highlight that on our horizontal axis. And what do you want on the vertical axis? So we'll highlight all the GPAs. Chart title, that's kind of nice. We could call it college success. You can call it anything you like, but we can call it college success. Plot linear regression line, we definitely want to do that. And I think we're good to go. Let's hit OK. Ignore the error message. There we go. That's just a glitch in my add-in in the software. Okay, so now, and you guys, remember, you can just right-click and copy-paste this into your Word document. But I'm going to write all the key information here right beside it. So notice that it says r squared is equal to 0.0153. We're going to need that really soon. That's called the coefficient of determination. So I'm just going to note to self. Coefficient of determination. Okay, and it's kind of hard to see because there's a dot over it, but you can see the equation of the least squares regression line, and so you would copy that. Sometimes we call that y hat. So that would be it looks like 0.0005x plus 2.442. Okay, and I believe we're going to be asked for that pretty soon in the lab as well. Okay, so I just want to do the mechanical part of the lab with you. I don't really want to answer everything, but I know I sometimes do because I have a tough time keeping my mouth shut. But describe the plot. So in part B it says describe the plot. So that's literally you looking at the plot and talking about, is there a strong positive association? Is there a weak association? And something I want you to be aware of, though, and this is a good thing to say, if r squared is equal to 0.0153, notice that that's not r. So you'd have to square root that, right? So I'm actually going to do that on my calculator. Remember, r is the correlation coefficient, so the square root of 0.0153 is actually a little bit higher. It's 12%, 0.124 approximately. So the correlation coefficient is 0.124. And what I would say is that the association appears to be weak. It has a slight positive direction, slight positive association, but it's weak. The correlation coefficient is only 0.12. Okay? Okay, so then in part C, it says, compute and interpret the correlation coefficient. So I kind of gave that away. If the computer will spit out r squared, right? And then you simply just have to take the square root of that, and that would be your correlation coefficient. And it's small. You know, you want your correlation coefficient to be like 0.98 or 0.99 to say there's a strong association between the variables. So that was very weak. It was only 12%. Part D, find the equation of the least squares regression line in the form that basically says y hat equals ax plus b. And it says, and graph the line on the scatter plot. Well, luckily, you know, when you use the Megastat add-in like that, it does it for you, as you just saw. So in terms of, I'll just pull it up. In terms of your project, you could literally, you know, I'll go off here on the corner, right-click on, copy, you know, pull up a Word document. I'll even pull up a new Word document. And I'm sure you guys are used to this by now. And then right-click again and just paste. See, so you can paste your, well, you know how to do that now. So you can paste that right into your Word document. Or, which would be this lab write-up right here. Okay? And then, let's see what else it is asking. So in part E, it says find the coefficient of determination, r squared, and what does it tell you about regression? Now, that's a vocabulary thing, and I'll help you out with that. R squared, we focused so much time on r in class, we didn't talk much about r squared. So r squared, a little definition, is the percent, basically is the percent of unexplained variation in y actually scratch that. I'm gonna say it in an easier way. I didn't mean unexplained. The easiest way I can say what r squared is it's the percent of variability in y that is explained by the least squares regression line. So it was, what was it originally? It was like 1%. I'll go back to that. Yeah, so r squared is 1%. It's like 0.015. So rounded up about 2. So, you know, if you had to make a sentence about that, you could say 1% or 1.5% of variation in y is explained by the least squares regression line. So what does that mean? Well, conversely, if 1% of the variability in y is explained by the least squares regression line, then conversely 99% of the variation in y is explained by some other variable. And, you know, that's why there's such a weak relationship. You would not want to use this trend line to make any predictions or extrapolations or anything like that. Okay? Okay, now we go a little deeper. So in part F, it says create a residual plot of the data. And we said that if we create a residual plot, we said that it should be patternless. You know, you shouldn't see patterns in the residuals. So Megastat makes it fairly easy to do that. I'll show you that in a sec. Okay, so we're going to go, make sure you can see where I'm clicking here. I just realized that might have been cut off. So I'm going to go to add-ins. I'm going to go to Megastat over here and back down to correlation and regression. But now I'm going to go over to regression analysis. Okay. So it's nice because you get to see this sort of scientific language that we were talking about. So it says X, your independent variable, and I already have that highlighted. And Y, highlight your dependent variable, which we already have. I put over here, then I put things that I wanted. So I said, let's put the output residuals. And then I wanted to see if it would, our residual plot is supposed to be our residuals against our explanatory variable. I've been having some glitches with the software, so I don't know if it'll do it. But I know it'll get the residuals for us. We can do the rest by sort of old-fashioned way. So let's hit OK. Ignore the error message. Great. Okay, so now what's nice about the Megastat is you've got this. Let's see if I can highlight this for you. See, it's just going to spit out the residuals right here. So you've got your GPA, you've got your predicted values. That would be your Y hats, okay? And you've got your residuals. So we want to basically plot, and here's interesting. The coefficients, notice that the output, a lot of people use SPSS or Minitab, and that has a similar kind of output. Notice the coefficients. That means when you have Y hat equals AX plus B, what this is telling you in a more formal way, the y-intercept being 2.4442, well, we knew that earlier because we saw it on our scatter plot. And notice the 0.0005, that was our slope, right? So it's telling you the important coefficients of your linear regression line, okay? These other things, confidence intervals and p-values and all that, we'll worry about that later down the road. Right now I just want you to grab the residuals, okay? And I noticed that it pulled up a blank chart, so it didn't plot the residuals for me, but that's okay. I'll scoot that over. I can plot the residuals myself. So what I'm going to do is I'm going to take all these residuals, okay, let's copy them, and let's put them back into Excel, back onto the spreadsheet. Make sure you're all the way at the top. Okay, so we put them in there. And then what we can do is we can make a scatter plot of our X variable against our residuals, which is what a residual plot is. I'll hit pause a second. Okay, so again, just reminding you that a residual plot is simply just a scatter plot with your X variable and then your residuals on the y-axis. So let's go back into add-ins, Megastat, back down, correlation and regression, over to scatter plot. But now this time, okay, horizontal axis, yes, we've highlighted our X data, which is good. But for the vertical axis, we want to highlight all those residuals instead. And then it says chart title. That's kind of neat because you can just say residual plot. And this time, I don't want a linear regression line running through it. And just go ahead and hit OK. And just ignore the message and hit OK. And there we go. And so what we said, remember we talked about that horn effect, homoscedasticity? So we're actually seeing that here. So we're seeing that, that horn kind of looks like a horn effect, that the residuals are getting see, here's the zero line, right here. Let me zoom in. See, this is the zero line for your residuals, and we're getting that sort of horn effect where as x tends towards infinity, it seems as though these are getting further away from the zero line. so it does not, the linear model is not good. And we knew that anyway based off of such a small correlation coefficient, but this is even further. So homoscedasticity, that's a good spelling word, cedasticity, it fails to meet that constraint. Sometimes that's called the constant error variance requirement. Your author basically says a strict requirement of the linear model is violated if you get this sort of horn effect here where as x increases, the residuals are moving further away from the zero line. Okay, hope that helps. Oh, I did want to say for part H, it says, are there any influential observations? If so, describe them. So influential observations would be observations that would drastically affect the value of your regression line. That if you took them out, would shift your regression line significantly. And I'll give you a big hint. Your author says that influential observations typically exist when the point is an outlier relative to the values of the explanatory variable. So it's kind of like when you have an outlier in the x direction. So I'm going to let you be creative and look back at the initial scatter plot to answer that one. Okay? And I'm going to head on to number 2. Okay, so this is only a 2-problem lab, and you'll notice that number 2 is very similar in nature to everything we just did. So it says the math department at a community college has designed math curriculum with a focus on problem solving. Consequently, they believe that scores on the reading placement test given to all entering students will be a good predictor of math success as well. To support their claim, they took a sample of students and recorded their reading placement test scores and their final exam scores from a problem-solving math course. The data is found on our tab that says Math Final, which we're going to look at in a moment. Create a placement score versus final exam grade scatter plot of the data. So I'm just going to highlight here, even though it doesn't blatantly say it, I'm sure you're imagining that the placement score is our X data and how you perform on the final exam is our Y, right? So fancier words there, that would be our explanatory variable versus our response variable. Okay, or you could say independent versus dependent. Okay, so let's start off, take a look at the data. Math Final, I go to this tab down here that says Math Final. So now you know how to do it. We go add-ins, Megastat, we go down to scatter plot, well, correlation and regression, and then scatter plot. Same thing, horizontal axis, we're going to highlight the reading placement scores. Vertical axis, we're going to highlight the math exam scores. Title, I'll let you create a title there, math success, something like that, success in math. Plot the linear regression line, we're probably going to need that, so we'll hit OK. And, looked like the software was glitchy there. Okay, so what I want to grab from that is several things. Clearly I want to grab the y-hat, let me put it in drawing mode here. So I want to grab the y-hat equals ax plus b, which is basically right here. We have our least squares regression line, so the 0.74x plus, and I'm rounding here, 23.3. Okay, and I'm grabbing r squared, which again is the coefficient of determination, which is 0.58. So that means that 58% of variation in y, which is 58% of the variation in final exam scores, can be explained by the least squares regression line. And you say, well, at least it's a majority, and another way of saying that is 58% can be accounted for by the least squares regression line. 42% of the variation in final exam scores are accounted by some other factors that are out there. So if r squared equals 0.58, remember that you have to take the square root of that. So square root of 0.58 is actually 0.76. So we're getting a little stronger here in terms of the association. So is it a strong positive association? No, strong to us means 0.98 or 0.99. So, you might say moderate positive. So moderate positive association. Still not strong. Okay. So I'm just going to kind of run through and make sure we have all our ducks in a row here. So you know how to make the scatter plot. Describe the plot we just kind of did in terms of is there a strong positive association or not. Calculate and interpret the correlation coefficient. You know how to do that now. Find the least squares regression line. That made it, the computer just sort of spit that out for us, so that made life very easy. Find the coefficient of determination, and what does it tell you? I did mention that, so I'll let you write that up. And let's just run through one more time how to create a residual plot of the data. Okay, that's the part that gets people sometimes. So, but again, having this megastat add-in, it just really it's like the easy button. So we'll go to megastat, we'll go down to correlation and regression, we'll go over to regression analysis this time, and we have our, oops, somehow it moved off of the chart. There we go. We have the reading test scores highlighted for our X data. Our Y data, see, sometimes it moves off of the tab, so you have to make sure our Y data, it's dancing around the final exam scores, which is good. I'm going to have output residuals here. Actually, that's going to be the only thing I put. And I'll go ahead and hit OK. Whoops, didn't like something. I'll hit plot residuals by observation. Maybe that's what it didn't like. Let me hit pause. I just realized when I looked up at my X data, it had something incorrect in there. So let me re-highlight the X values. So you can kind of tell it should be sort of symmetric there. And hit OK. Ignore that message. And now I'm going to scoot that over there. Ooh, SAT score. Oh, that was an old plot. We'll move that over. Okay. So now I'm going to grab all the residuals. Let me move this over as well. You see it says final exam scores, and then it says has your predicted Y value. So it's kind of like observed Y value. Well, this is a good time to say this. Remember when we were first learning residuals, and we said it's going to be Y minus Y hat is how you compute a residual? So notice what the computer's doing. It's saying, hey, here's your observed values of Y, your final exam scores. Here's your predicted values of Y. Those are your Y hats. And then your residuals. So it's doing the Y minus Y hat business for you, basically. Okay? Kind of like we did on the graphing calculator. So let's go ahead and grab all those residuals one more time. Copy. And let's open back the spreadsheet. Paste. Okay. Oops, I don't have those shifted. I want to make sure you have them shifted correctly. Let me paste them right here. So they're side by side. Okay, and then again, the residual plot is just a scatter plot of your X versus your residuals. So we'll go back over to scatter plot. The horizontal axis, make sure it's dancing around your X data. But vertical axis, this time make sure you've highlighted all your residuals. Okay? And this time I'm not going to plot the linear regression line because I'm making a residual plot. So I would, even right here, I would remind myself. So that way you know what all your plots are. Okay, hit OK. Ignore that. There we go. So now we have a residual plot. We've got our reading test scores on the x-axis. And, you know, residuals, you're always going to, you'll kind of be triggered that you did it right because you'll always notice your 0 line right here. Okay, and this actually is a good residual plot. Notice it's patternless. It's not like, in other words, I'm making this up here, but let's say here's your 0 line. If your residuals go like this, well, that's not patternless, you know, that's parabolic. Or, you know, if your residuals go like this, you know, that's not patternless either, right? That's sort of sinusoidal. So these residuals are patternless. So we have pretty good evidence to say our linear model is definitely a lot better than it was in the first example, so we could go with this model. Okay, we'd like to see the correlation coefficient as 0.99, be better, but it's good evidence to say we can use it to make predictions. Okay. So what I would say here, it says, do you think the least squares regression line is a good model? I would say, you know, it's a decent model, but because the correlation coefficient isn't in the 90s range, 0.98, 0.99, there's got to be a better model out there. It's a decent model, though, especially when you compare it with the other one, which only had a correlation coefficient in like 12%. Are there any influential observations? I'm going to let you think about that, but I will give you a hint. If you look back, you always want to look back at your original scatter plot. So I'll scoot that over here. So are there any observations that might significantly, and you can even run this experiment. I'll give you a hint here. Are there any observations that might significantly affect the value of little r if I tossed it out? So I'm looking at this, I'm thinking, maybe this one? Oops, my pen won't let me highlight it. Let me see. Maybe this observation. So what you could do is you could try tossing it and see if it drastically affects the value of r, or r squared. I don't think it will. Because you're looking for outliers in the x direction. So in other words, if there was a point out here, that would drag the line down significantly, and that, right? Or if there was a point, let's say, well, these points are still fairly close to the line. Yeah, so a point out here basically would be influential, but I don't really see any here. Okay? Let's make sure we have everything we needed. I'll go back to the write-up. Yeah, and that's just I believe that's just a 2-problem lab. Yep. So good luck on that one. I think that should go well for you.